Well, in Fayetteville, Palmer amaranth would be called Amaranthus palmeri, which was discovered by Edward Palmer in the late 1800s. It's an erect, branched summer annual, and as Bob just said, I thought maybe you didn't know what dioecious might be, but now we know. Male and female plants, okay, separate. It's indigenous to Rio Grande, South Texas. So blame the problem on Texas, okay? And it has followed us humans across the southeast. As we go somewhere, it follows. And there are presently 7 other Amaranthus species here in the Mid-South. Well, today I want to talk about, in my presentation, a dominant weed and the importance of weed biology and how we can use that information to manage that weed problem. And I'm going to look at 5 different areas: seed germination and emergence. Then we're going to go to growth and development, interference potential, reproduction and seed production, and then finally seed dormancy and viability. Well, what came first? Chicken or the egg? Quite a bit of controversy there. Well, I think there's no question here the Palmer amaranth seed is how you got the problem. And if we look, the typical question from a producer would be, where did that come from? Well, it's an extremely small, round, black, shiny, utricle fruit. It's got a mechanically resistant seed coat. It spreads very easily, dispersed by natural and artificial. Probably here in Arkansas, in the Mid-South, wind and water are the 2 primary things. And then, guess what? Us humans. And that's our equipment. We go from one field to the next, our combines, our crop seed, you name it. And so really the resistance problem is just a numbers game. The more you got out there, the more potential you got for resistance. If we look at the germination and emergence of Palmer, if we just define what germination means, we're just saying that it's an interaction of the environmental conditions, light, moisture, okay, and temperature, and in the physiological state of readiness of that seed. So when all those line up, here comes your plant. It's a continuous emerger all the way from April to October. It best emerges usually in alternating temperatures greater than 68 degrees Fahrenheit. And guess what? Palmer is always the first of all those pigweeds that come out of the ground. If you get soil temperatures around 64 degrees at 2 inches, it basically initiates germination of Palmer. So you can see pretty quickly that temperature is very important in the emergence of Palmer amaranth, and it overrides light. Of course, moisture is also important, but that's there. Now, when you're talking about seedling emergence, well, we got to understand what we're doing here and how critical that is to improving your weed management systems. And I think it'll be pretty obvious here that you can't let that Palmer come up and get started and produce seed. There's really no good data on how many, once that Palmer produces seed and deposits it into the soil, how many seeds actually come up the next year. It's somewhere between 1 and 5%, and it may even be more than that. But 1 and 5% of 200,000 to 600,000 seeds is more than you need. Peak emergence, anytime you get good rainfall, you get the temperature, your canopy's open, the light gets there, you're going to get emergence of Palmer all the way through the growing season, so you've got to stay on it. And Dr. Norsworthy and Jada have shown that when you close the canopy, you can reduce germination or emergence about 74%. So close the rows. Now, growth and development. Well, guess what? Palmer amaranth is a C4 plant. In other words, it's got things other plants don't have. It's very highly efficient in photosynthesis. If you look at it versus the other pigweed species out there, it's a lot bigger, 65% more dry matter, got greater leaf area, greater growth rate, and it's a taller plant. So you got a problem with it, and you can see how it dominates a situation very quickly. It can grow about 1.25 inches a day, and it'll get greater than 6.5 feet tall with a stem diameter of 3 to 4 inches. Now, Dr. Bond has shown that all the accessions that he collected throughout the South and Arkansas, that Arkansas has a very good, diverse morphological characteristics out there in the palmer. This is a root system of a 3-week-old palmer. Notice how massive it is, all kinds of root hairs, and so it's got a massive root system taking up moisture, nutrients, and again, it's got a low water use efficiency, so it's a luxury consumer, but it doesn't need that much water to produce a pound of dry matter. Now, interference potential. Well, when Dr. Baldwin and I were working a few years ago, we thought common cuckleburr was the major deal. Can anybody even identify a common cuckleburr? You even seen one lately? Okay. Well, that was the biggie. Well, right now, Palmer amaranth is the biggie. And when you're talking about interference in your crops, it's a dominant plant. It's got another thing that most other plants don't have, and that's a allelopathic potential. So in other words, it not only is very aggressive, but it gives off chemicals that prevent the other plants around it from growing, inhibits their growth, and allows it to establish a stand. Heterogeneous species, it's got tremendous genetic potential, and it's adapted, as we have seen, to just about anything we've done. And resistant potential was there in that population. It's just a matter of time when it shows up. Now, looking at the interference potential, in other words, the competition in allelopathy, cotton, and one plant every 3.3 feet or a meter, 54%. Corn, only about 18%. So you can see it's very competitive. Now, okay, we've got that plant up. We've got it growing. Now, what is it going to be thinking about? Plants do think, right? Yeah. Most of you guys, when you're younger, you thought about the same thing. Something about reproduction. Well, guess what? That female palmer is the one that produces seed, and you can't tell the male from the female until they go into reproductive structures, okay? The female will produce 200, 600,000 seed up till about June, July, and after that it goes down. Now, this is data out of California, so I'm not for sure when you look out there on that one that your kin's got you doing. I would think maybe you're going to go higher than that. So in the Delta, we got a different situation. Guess what? If you get under stress, like an application of glyphosate, you don't kill the plant, the male can produce seeds. Okay? Mother plant, from the top to about the lower middle third, it produces about 67% or 72% of the germinal seed. The lower part, not as much, but most of those seeds have already gone into dormancy. And we'll talk about that here in a minute. How many of you have noticed your palmer out there in the field? We're always getting people send in a plant and they don't know what it is. Well, there's all kinds of variability. And if you'll notice, what did I do? Go 2 slides? I think I did. No, okay. I want to make one point right here. I forgot. Most of you would think the female plant is the soft, cuddly plant. Okay? Oh, yeah, you know. And the male's the big, robust guy, well, big, strong. Well, you're wrong. The male is the little soft, cuddly. The female has those stiff bracts when you're walking through. They cause you problems. So just rethink your thinking, okay? Now, when they flower, again, there's going to be 3 or 4 males around one big female, okay, in general. The flowers, as you see here, they're inconspicuous. And then about 2 weeks after pollination occurs, you've got viable seed, okay? And they flower about 5 to 9 weeks after planting, in that March to July, and about 3 to 4 days after planting of your crop or emergence in the later part of the year, okay? So, now, from this information, it's pretty obvious that Palmer amaranth does not have an economic optimum threshold anymore. And that's considering that herbicide resistance. I know when I was earlier in my career, we were working with economic thresholds, competitive thresholds. Well, now that's basically saying you can't let one go to seed out in your field, or you're going to have a major problem. Now, okay, here we are. We getting ready to harvest. Back side of the field, we run into a patch looks like that. Does anybody see the female? Well, do we just run the dang combine through there, or what do we do? Or we go gather it, Eric? Well, you've already spread seed everywhere, so you're not doing any good there. So once you let that seed go in your field, you and your grandkids have got a problem, okay? And that brings up the subject of soil seed bank, and I just want to illustrate what's going on there so you guys a better idea. Now, here's a soil seed bank. It's just like your piggy bank at home. Deposits, storage, withdrawals, okay? Notice that there's a dormant, the major portion of that seed bank is dormant, then there's non-dormant. And those guys are just waiting there for the right environmental, physiological things to occur. You get germination, goes over, grows and develops. Mother plant, guess what? The female deposits seed, there's herbivority, and if you leave that seed in that soil seed bank long enough, it will decay just like us old folks might do, okay? Now, it's been shown about 10% of that 200, 300, whatever thousand seed are not viable seed, okay? They didn't develop right. The older seeds in general, the ones that stayed on the plant longer, are usually dormant, so they're going to go down in that seed bank and they're not going to come up that first year. Late season cohorts, and what I'm saying here, as that plant goes through the season, every time you get the right conditions, you're going to get a flush of plants. Well, a lot of times, later in the season, the interference from the weed, the other palmers, and your crop will reduce that stand about 50%. And the other thing is predation is coming into play, and it's up as high as 50%. Some people think birds, earthworms, carotid beetles, you name it, are feeding on those seeds. Now, well, okay. What happened here? You know, I think maybe last year I didn't get out of the truck and take that plant out. Now I got a circle of 200 or 300 plants. And if I don't do anything, within 2 years, I've probably got that whole field full of Palmer amaranth. If we started now, in other words, that's almost too late to take those out. You've already got flower set, you've already got viable seed, your history, okay? So you got to get it out earlier, and if you kept it out with no reseeding for at least 6 years, you might have your problem solved, but that's going to be pretty hard. You don't have enough kids at the house to go out and take those out, okay? So basically, on a large scale, we got a problem, okay? So the big thing is prevent seed production, okay? The first one you see, don't wait till it sets flower and decide that you think you need to take that out. I don't care whether it's a resistant plant or just a really susceptible plant, a palmer. Now, in summary, if we just looked at what I've said today, the big point is it only takes one seed. One seed in your field, you can set yourself up for failure. It's a continuous germinator. It's a C4 plant, tremendous growth and reproductive potential. Got greater interference and allelopathy than anything else, so it'll just dominate. Dr. Baldwin had the best common cockleburr field in the country 20 years ago, didn't you, Ford? And he one year decided to put in a Palmer amaranth test, and within 4 years, his whole field was Palmer amaranth. Okay? Unlimited genetic potential. Those pigweeds have no morals. They'll cross with anything going. Okay? So they got unlimited genetic potential. They're a dioecious plant. You got to stop reproduction, and if you don't, it's going to take you at least 6 years of complete no reproduction to stop that problem. Okay? With that, I would just say there's no question about the Palmer is their number one problem, and I'll open it up to questions.